Okay, here's another example of growth and decay, and this is number 4. A population of fruit fly obeys the law of uninhibited growth. There are 1,200 fruit flies initially. There are 3,800 after 4 days. What is the size of the population after 9 days? So we have to this is number 4 here. So use our basic formula, the amount at time t, or you can use the population, equals the amount at 0, e to the kt, or you could write it like this: the population equals the initial population, e to the kt. And we know that for the fruit flies, we started with 1,200, so p sub 0, my population at 0 is 1,200. Okay, and that's all. We don't know what k is. T are open, so you have to figure out the k, but they tell us that when p of t equals 3,800, t is equal to 4. All right? Now that's the key. That's how we're going to find the k. There are 1,200 fruit flies initially, and there are 3,800 after 4 days, so we can find the k that way. So remember, we have to find the k because we need that to finish off the formula. Otherwise, we'll be having one too many unknown elements. So we'll find the k first, so find k. So I've got 3,800. My p sub 0 is 1,200. And I've got e to the k, which I don't know, but I know t is 4. See, so I should be able to find out what k is that way. Okay? I divide both sides by 3,800. I'm sorry, divide both sides by 1,200, excuse me. And these are canceled, these are canceled. I got 38 over 12, and I can reduce that to be 19 over 6. I can put the 4 in front, 4k, take the natural log of both sides. And let me do this up here so I save a little room. So ln of 19 over 6 equals 4k ln of e, which goes to 1. So then I just divide both sides by 4, and k equals and I can multiply by 1/4, so 1/4 natural log of 19 over 6. And I could also write that as 0.25. So if you can, change it to decimal. You don't have to, but you can. Okay. All right. So now we got our k, so now we can use our formula. And A, they want to know, go back and look at the problem, and letter A says, what will the size of the population be after 9 days? So I'm looking for P of 9. And remember, you can always pause this and go back if it gets a little confusing. P of 9 equals, my initial population is still 1,200. I start out with 1,200. E to the k, now I know what the k is now. It's 0.25 times the natural log of 19 over 6 times t. All right, so it looks a little more complicated because you got this written out, but that's just our k. All right, and 19 over 6 is greater than 0, so I mean this is going to be positive, so it is exponential growth. All right, so remember we got to find our k first, and they give us enough data to find that. They'll give us a particular, they gave us a particular time and a particular amount, so we put that in with our initial amount, and we found out what K was, and now we have a general formula, and we can put this in. All right? I probably should have written the actual formula could have been P of T equals 1200 times e to the 0.25 ln of 19 over 6 t. So that's your general formula over here, you see. P of t equals 1200 times e to this. For this particular population, this is going to work because we had an estimate of, or we had an example of what happens with this population, so it allows us to find the k. All right, so now we just put this in here, and we want to find p of 9, so every time I see a t, I put a 9. Oops. I'm going to put a 9 there, pardon me. T is 9. And then we just calculate that out. And that's put in your calculator. So here's the way I would put this in the calculator. I would put 1200 times, or put next to the E, and then on our little calculators we have this, and then I'm going to put the 9 in front, 9 times 0.25 times ln of, I got to put parentheses because I got a fraction, 19 divided by 6, parentheses for that, and a parentheses for the exponent. All right, that's how you would put it in your calculators. You might have some extra parentheses in the ones with the caret. So let's try that with the little calculator over here. So on 1200, then shift ln, and I get e, parentheses, and I'm going to put 9, I'll just use times 0.25 times natural log, parentheses, 19 divided by 6, parentheses around that fraction, and a parentheses for the exponent, and I should get an answer of 16,052.27. $16,052.27. That's my P of 9. In other words, that's how many I have after, I think it's days, isn't it? Yep, days. All right. Fruit flies. Okay, so I got 16,000 flies after 9 days. Okay, you can see that in your calculator. 16,052.27. All right. So see, once we have our formula, no problem. Like I said, you might have some extra parentheses with the caret, but maybe not too many because this is, you have parentheses for the log anyway, so this should be pretty close on both calculators. Okay, letter B. How long will it be until there are 100,000 fruit flies? How many days for 100,000? So I still use my same formula. P of t equals 1200 e to the 0.25 ln of 19 over 6 t, and we want to know what t is going to be when this is 10,000, 100,000. Well, that's 0.25, excuse me, ln of, so you're looking for t here. Get this up a little bit. Okay. So I'll divide both sides by 1200. A bunch of zeros cancel out here. So I can cancel those. So I got 1,000 divided by 12. And I know 4 goes into 1,000, 250, 4 goes into 12 3 times. So I got 250 divided by 3 equals e to the 0.25 natural log of 19 over 6 t. And then I'll take the natural log of both sides to get this down in front so I can solve for t. So natural log of 250 divided by 3 equals the natural log of e, 0.25, natural log of 19 over 6 t. Bring that in front. Equals 0.25. And in this case, it might be, I can write this as 1/4. Natural log of 19 over 6, that's a 6, excuse me, t times the natural log of e, which goes to 1. Now this is the same thing. It might be better to think of this as 1/4, so I can multiply both sides by 4. Make it a little bit easier than dividing. We calculate it out. So I just change this to 1/4 again, and then I multiply. So I've got 4 times so just change that to 1/4, and I multiply. I've got 4 times of 250 divided by 3. All right, and I'll divide by natural log of 19 over 6, and that equals t. Okay? I kind of ran out of room here, so let me kind of rewrite this over here so you can see this. So it's going to be 4 natural log of 250 divided by 3, all divided by the natural log of 19 divided by 6, and that's going to equal t. Okay, so I took the 0.25, made it 1/4 so I can multiply. So I wouldn't have a decimal down here. Better to have it up there. Okay? Now I put that on my calculator carefully. So I go in the calculator like this. Now it's going to be the top of the fraction, so I need to put a parentheses around here. 4 ln, and then I got 250 divided by 3. All right? And then that's going to be divided by, so I got to put parentheses around this whole thing. And that's going to be divided by parentheses, divided by, and then I just have one log, so log parentheses 19 divided by 6. So that's how that's going to go in your calculator. So this is going to be the top. So I need a parentheses around that because I don't want to, because I got 2 elements at the top. 4 times the natural log of 250 divided by 3. So that's my top there, and there's my fraction, and then divided by the natural log of 19 over 6, and we should get an answer if we do that carefully. Sorry, zoom in, I'm losing some of my stuff there, excuse me, okay? So again, 4 natural log 250 divided by 3, natural log 19 divided by 6. Turn this on. Okay, so what do we got here? Parentheses, 4 ln natural log, parentheses for the fraction, 250 divided by 3, and a parentheses around that, and that for that log division, and a parentheses around the top of that whole big fraction, and that's going to be divided by natural log, and a parentheses for the fraction, 19 divided by 6, parentheses, equals. And we got an answer. Okay, that's about our time, which is about 15.34, actually about 0.35. And that's going to be days. How long would it be? Because this is in days. In 15 days. That's T. All right. So you can see there's a bit of work there. Let me pull this out a little bit so you can see everything there. I should have used a different sheet of paper. I was kind of running out of room here. All right. But hopefully that makes sense. Okay, just have to be real careful on these two-parters. If I bring this out farther, there's a lot of stuff going on there. There you go. Okay, so take a look at that, go through it, and then try it on your own. Make sure that you can do all the calculations and follow what's happening, follow the reasoning. That should help.